We often imagine the death of a star as a sudden, violent event, a cosmic light switch flipping off, plunging the world into instant chaos. But the reality of stellar physics is far more complex, a slow-motion tragedy played out over billions of years. However, if we fast forward through the eons to the theoretical endpoint, the moment the sun transitions from a dim ember to a dead rock, we find a scenario of haunting beauty and terrifying absolute zero. This is a simulation of the last second, not just the moment the light goes out, but the events leading up to the final breath of the solar system. Number. The prelude, the red giant expansion. 5 billion years from now, long before the sun goes dark, it will become an engine of destruction. As the sun exhausts the hydrogen fuel in its core, the delicate balance between gravity pulling inward and nuclear fusion pushing outward breaks down. The core will collapse and heat up, igniting a shell of burning hydrogen around it. This extra heat will cause the sun's outer layers to expand wildly. It will transform into a ***, red giant asterisk. 1. The consumption ***, Mercury and Venus will be vaporized. 2. Earth's fate the sun will expand to roughly 200 times its current radius. Earth may be swallowed, or the loss of the sun's mass might loosen its gravitational grip, pushing Earth's orbit out just enough to survive. However, survival is relative. The oceans will have boiled away eons ago. The atmosphere will be stripped. Earth will be a scorched, molten rock. Number. The Great Exhale, the planetary nebula. Eventually, the red giant becomes unstable. In a series of thermal pulses, the sun will shed its outer layers, puffing them gently into deep space. This creates a ***, planetary nebula ***, a glowing shell of ionized gas that will look beautiful to alien astronomers light years away. What remains in the center is the exposed core of the dead star, a ***, white dwarf ***. This object is incredibly dense, about the size of Earth, but retaining about half the sun's original mass. It has no fusion. No new energy is being created. It is simply a hot ember, radiating its stored heat into the cold vacuum. Number. The long twilight. The era of the White Dwarf. This is where the concept of the last second stretches into deep time. The White Dwarf will shine for trillions of years. Initially, it is white-hot, emitting X-rays and ultraviolet light. Over eons, it cools down. White, yellow, red, ***. As it loses thermal energy, the star's color shifts. The freeze, ***. Any surviving planets like Mars or the outer gas giants will freeze completely. Jupiter will become a cold, dark sphere. Number. The last second. Transition to Black Dwarf. This brings us to the core of your question. The theoretical last second. This event occurs roughly a quadrillion years in the future. The White Dwarf has cooled to the point where its surface temperature drops near absolute zero. It is no longer energetic enough to emit visible light. It is becoming a ***Black Dwarf. A theoretical stellar remnant that no telescopes have yet seen, because the universe is not old enough for one to have formed. T-1 second, the final flicker. Imagine standing on the surface of a frozen, dead Earth, looking up at the sky. The visual, The sun is now just a dull, deep red sphere, barely distinguishable from the blackness of space. It looks like a dying coal in a campfire, fading into ash. The physics, The surface temperature drops below the Draper point approx 798 K, or 525 degrees Celsius, where objects stop glowing with visible incandescence. The event, ***. In this final second, the last visible photon escapes the surface. The wavelength shifts from the deepest visible red into the infrared spectrum. T+1 second. The Great Darkness. The sun is technically still there. Its gravity still holds the corpses of the planets in orbit, but visually, it has vanished. 1. Asterisk asterisk. The sky. Asterisk asterisk. Without the sun's faint glow, the sky is dominated entirely by distant stars, if they haven't all burned out as well. The solar system is now a graveyard of ghosts, orbiting an invisible tombstone. 2. Asterisk asterisk. Thermal collapse. Asterisk asterisk. The only heat reaching Earth now is the background radiation of the universe. Number. Simulation. The cooling of Earth. If we assume Earth survived the red giant phase, a generous assumption, the cooling process following the sun's transition to a black dwarf would be the final nail in the coffin of entropy. 1. The atmosphere. By this point, Earth's atmosphere would likely have frozen onto the surface long ago. Asterisk, asterisk, asterisk. Nitrogen snow, asterisk, asterisk. As temperatures drop below -210 degrees Celsius, -346 degrees Fahrenheit, nitrogen turns to liquid and then freezes solid. Asterisk, asterisk, asterisk. Oxygen ice. Asterisk, asterisk, oxygen freezes shortly after. Asterisk. The surface of Earth is covered in a blanket of frozen air, meters thick, burying the ruins of human civilization. 2. The geothermal core. While the sun goes dark, Earth's core might still retain some residual heat from radioactive decay. This creates a cruel irony. The surface is near absolute zero, but miles beneath the crust, pockets of warmth might persist. However, without solar energy, there is no weather, no water cycle, and no life on the surface. Number. Could humanity die-migrate? The survival probability. The timeline of stellar evolution gives humanity an incredible advantage. Asterisk, asterisk. Time, asterisk, asterisk. We have roughly 1 billion years before the sun becomes too hot for life on Earth, even before the red giant phase. Here is the strategic analysis of human migration. Phase 1. Mars and the outer moons 1 billion years from now. As the sun heats up, the Goldilocks zone, habitable zone, moves outward. Asterisk, asterisk, asterisk. Mars, asterisk, asterisk, will become warmer and potentially terraformable. Asterisk, asterisk, asterisk. Europa and Titan. Asterisk, asterisk. The icy moons of Jupiter and Saturn might melt, creating water worlds. Humanity could migrate to these outer bastions. Phase 2. Interstellar migration. 4 billion years from now. Before the sun enters the red giant phase, the entire solar system becomes a death trap. Humanity must times leave. Asterisk, asterisk, asterisk. The challenge, asterisk, asterisk. The distances are vast. Proxima Centauri is 4.2 light-years away. Asterisk, asterisk, asterisk. The technology, asterisk, asterisk. We would require generation ships arcs, where generations live and die, or cryosleep technology. Asterisk, asterisk, asterisk. The destination, asterisk, asterisk. We would look for K-type orange dwarf or M-type red dwarf stars, which burn their fuel much slower and live longer than our Sunday. Phase 3. The post-biological age. By the time the sun becomes a black dwarf, trillions of years later, humanity will likely no longer be biological. Asterisk, asterisk, asterisk. Digital consciousness. Asterisk, asterisk. If we upload our minds into machines or energy lattices, we become less dependent on the Goldilocks zone of temperature. Asterisk, asterisk, asterisk. Harvesting black holes. Asterisk, asterisk. In a dying universe where stars have gone out, advanced civilizations might orbit black holes, harvesting the rotational energy Penrose process to power their digital simulations. Number conclusion. The quiet end. The last second of the sun is not an explosion. It is a whimper. It is the moment entropy wins. When the sun finally fades from visible red to invisible infrared, it marks the end of the story that began 4.6 billion years ago in a swirling cloud of gas. If a human observer were somehow present to witness that final second, they would feel the profound cold of the void. The sun would not turn off abruptly. It would simply fade until the eyes could no longer distinguish the star from the darkness of the deep universe. The planets would continue to orbit in the dark, held by the gravity of an invisible ghost, drifting silently through eternity.